A note before you listen. This episode was produced in NotebookLM, the AI tool that serves as AI Frankly's executive producer. You'll hear 2 AI hosts work through the 3 local voice assistant builds and the receipts behind them. NotebookLM gets some technical pronunciations creatively wrong. Ollama comes out about 4 different ways. Kokoro mangles into kokoaro at one point. The ideas land. The pronunciation sometimes doesn't. We use AI to talk about AI. When the AI hits its limit, we point at it instead of hiding it. Full written article with all the corrections and source links at aifrankly.substack.com.
Picture this. You're standing in your kitchen.
Okay.
Your hands are just completely covered in flour or like maybe raw chicken, whatever it is. It's an absolute mess.
Oh, yeah, the classic cooking disaster scenario.
Exactly. And the timer you set for the oven goes off and it is just blaring. So naturally you yell out to your smart speaker across the room, stop the timer.
Right. And it stops.
It does. The beeping stops. But then, without missing a single beat, that cheerful little cylinder of plastic sitting on your counter says, by the way, I noticed you use timers a lot.
Yeah.
Would you be interested in buying a highly rated air fryer for $49.99?
Oh, wow. Yeah. That's the exact moment the entire illusion of the smart home just completely shatters.
Right.
You realize you don't actually own a helpful digital assistant at all. You've basically invited a very patient, very persistent door-to-door salesperson to live permanently on your kitchen counter.
Yeah, and that exact scenario, that isn't just some hypothetical nightmare I made up. That is the factual catalyst for why a software engineering leader named Kunal Ganglani decided he had finally had enough.
Oh, he's the one who ripped it out, right?
Literally.
Yeah.
He physically ripped his Amazon Echo out of the wall and embarked on this massive, highly complex migration to a completely private, localized smart home setup.
Good for him. I mean, it's tempting.
It is, because if you've ever had that moment of sheer, dystopian annoyance, or if you just value your privacy even a little bit, you've probably wondered, how hard is it, really, to build my own version of Jarvis?
Right. A system that actually lives entirely inside the physical walls of your house.
Yes, exactly. One that doesn't harvest your data for targeted ads and definitely doesn't try to upsell you on kitchen appliances while you're just trying to, cook dinner.
And that's a question that is absolutely dominating tech circles right now in mid-2026.
Yeah, it's everywhere.
Because the technology has advanced so rapidly, right? And the open source tools, theoretically, they are out there. But the reality of actually implementing them, that's a different story.
It's rough.
Taking a piece of software that a developer swears, works perfectly on my machine, and trying to make it work flawlessly for everyone in your house, your kids, your partner, your guests, it's a massive leap. It is basically the Wild West out there right now in terms of local artificial intelligence deployment.
Which is exactly why today, on this deep dive, we are unpacking a fascinating, incredibly detailed technical breakdown from a source called AI, frankly.
Yeah, this is a great piece.
It's so thorough. The author of this piece didn't just write some philosophical think piece about data privacy. They actually put in the late nights, the frustrating debugging sessions, the trial and error to test 3 very distinct ways to build a truly local voice assistant.
They really brought the receipts.
They documented all the failures. No cloud data harvesting, no corporate eavesdropping, just you and a private AI.
And we really need to look at exactly where they started, because the author's approach is highly methodical. They didn't just jump straight into wiring up microphones to the ceiling.
Thank goodness.
Right. They started with what they call the beginner level. It's basically a 10-minute setup that is completely free, utilizing a web browser.
Okay, let's unpack this, because they call this the browser Jarvis. And on paper, it sounds almost too easy. They used a combination of 2 open source tools, Ollama, that's Ollama, and OpenWebUI.
Right.
But before we get into the experience of using it, I need to understand what these tools actually are, because even beginner in the local AI space sounds like an entirely different language. What is Ollama actually doing under the hood?
So think of Alama as essentially the physical engine block of your AI.
Okay, the engine block.
Yeah. When you interact with a commercial system like ChatGPT, the processing of that massive neural network happens on huge server farms in a data center somewhere in California or Virginia.
Right, miles and miles away.
Exactly. Alama is a piece of software that pulls that entire process down to your local machine. It manages downloading the AI models, it loads them into your computer's local memory, And it basically allocates your computer's CPU or graphics card to do the actual mathematical processing of the text.
So it's the environment where everything executes.
Yes, it's the execution environment. It does the heavy lifting.
Okay, so Ollama is doing the math, but I can't just talk to an engine block sitting on the floor. I need, like, a steering wheel.
Right. An engine on a garage floor isn't very useful to a driver. You need a dashboard.
Yeah.
And that is exactly what OpenWebUI provides.
Ah, okay. The UI stands for user interface.
Exactly. It's a graphical interface that you run locally. It looks and feels almost identical to the sleek chat windows you're already used to with commercial AIs.
Oh, nice.
But instead of routing your text out to the public internet, it connects internally, right, on your machine, directly to your local Alama engine.
Okay, that makes sense. And the author notes they ran this specific setup inside something called a Docker container.
Yes, very important detail.
I see this term constantly when we talk about self-hosting things. What actually is a Docker container, and why are we using it here instead of just, double-clicking an installer file like a normal program?
That's a crucial part of the architecture. So imagine your computer's operating system as this massive, slightly disorganized warehouse.
Okay, I'm picturing it.
If you just install a really complex piece of software directly into it, that software scatters its files, its dependencies, its specific library requirements all over the warehouse.
Sounds messy.
It is. Eventually, two different programs might need totally different versions of the exact same file, and everything just crashes. It's a conflict.
Oh, it's like trying to build a Lego set, but dumping all the pieces into a bin that already has 5 other half-built Lego sets in it.
Precisely. That is a perfect analogy. So Docker solves this by putting the software into a literal standardized shipping container.
Oh, I see.
OpenWebUI, along with every single specific file and dependency it needs to run perfectly, is packed into an isolated virtual box.
So it brings its own Legos.
Exactly. When you run it, it operates inside that box, completely cordoned off from the rest of your computer's operating system. It basically guarantees that if the software worked on the developer's machine, it will work exactly the same way on your machine, because the internal environment to that container is identical.
Okay, so we have our engine in Alama, we have our dashboard in OpenWebUI, and it's all running cleanly inside this Docker container.
Yep, you've got it.
And just for context, the author ran this on a machine with 16 gigabytes of RAM and a pretty recent CPU.
Right. So you don't need some $10,000 supercomputer, but you do need a solid modern laptop.
Yeah, so you open your browser, you see the chat interface, you click the little microphone icon on the screen, and you say hello. It types out your words, feeds it to the local AI, and the local AI responds.
And boom, you're done.
Right. I have a private local voice assistant. I did it. Privacy achieved.
Wow. This is the trap. This is the exact illusion of local AI that the author exposes in this first recipe.
Wait, what do you mean?
Because if you just follow those basic steps and you click the microphone in your browser and you talk, your voice audio is almost certainly still being sent directly to Google's cloud servers.
Wait, back up. How is that even possible? I just downloaded everything to my local machine. I'm running Ollama locally. I'm running the interface locally. Where does Google even enter the equation?
It's an incredibly sneaky dependency.
I feel betrayed already.
I know. When you click that microphone icon in a web browser, like Google Chrome or Safari, the OpenWebUI software relies on the browser's built-in web speech API to handle the actual job of translating your spoken audio into text.
Okay, and how does Chrome do that transcription?
It doesn't do it locally. It takes the audio snippet from your microphone, packages up, sends it over the public internet to Google's massive cloud speech-to-text servers, gets the transcribed text back, and drops that text into your local OpenWebUI text box.
You have got to be kidding me.
I am not.
So my AI model is local.
Yes.
The text it generates is local. But the raw, unedited audio recording of my actual voice inside my house just bypassed all my local security and went straight to the cloud anyway.
Yes, it went right out the front door. It is a perfect example of how deeply entrenched cloud dependencies are in modern software. We are so used to the convenience of the cloud that developers just default to it for complex tasks like speech transcription because it guarantees a smooth, highly accurate user experience.
Wow. It's like going totally off the grid, right?
Yeah.
You buy a cabin in the woods, you install solar panels, you grow your own food, you are completely independent, but you still route your home's plumbing directly into the city's municipal water supply because you just didn't feel like digging a well.
That is exactly it.
You've compromised your entire independent infrastructure without even realizing it because the pipe was hidden underground.
That is exactly what is happening mechanically here. You've built a secure local processing environment, but you relied on an insecure, cloud-based transport mechanism for the input.
Unbelievable.
Now, the author notes that you can fix this.
Okay.
You can make recipe 1 truly local, but you have to bypass the browser's default speech recognition and manually configure a local model called Whisper.
Ah, Whisper. That's the open source speech-to-text model originally developed by OpenAI, right?
Correct. But unlike their cloud APIs, you can download the Whisper weights and run it entirely on your own hardware.
Okay.
But doing so completely changes the friction level of this 10-minute beginner setup. It demands significantly more configuration, you have to route the audio correctly, and crucially, it demands a lot more hardware power.
Because it's heavy.
Very heavy. Transcribing audio locally in real time is mathematically exhausting for a computer.
Really? Just turning sound into words?
Oh yeah. It involves taking the raw acoustic waveform of your voice, breaking it down into spectrograms, analyzing the frequencies, and mapping those phones to text using a neural network. It's intense.
So if I'm understanding this correctly, recipe 1, this browser Jarvis, is essentially a parlor trick unless you really know what you are doing.
Basically, yeah.
And even if you do manage to set up Whisper locally, you still have to physically walk over to your laptop, use a mouse to click a microphone button, hold it down, speak, and let go.
Right, like a walkie-talkie.
Yeah. It's completely useless if my hands are covered in raw chicken. I can't click a mouse.
Exactly. It's a great proof of concept for running a language model locally, but it completely fails the fundamental test of being a hands-free assistant. If we want a fluid conversation that actually feels like talking to a real person, we have to completely abandon the browser approach. We have to move down the stack.
Okay, which forces us right into recipe 2, the one-command Jarvis.
Right, the intermediate path.
So the author categorizes this as intermediate. It takes roughly 30 to 60 minutes to deploy, and it relies on a specific open-source project repository, literally called Local Voice AI.
A very straightforward name.
The promise here is that you clone the code from GitHub to your machine, you run a single startup command in your terminal, and you are presented with a web-based voice assistant that you can simply converse with, entirely hands-free, no clicking required.
But the phrase, single startup command, hides a monstrously complex stack of technologies working together underneath.
Oh, I bet.
When you run that command, you are orchestrating a symphony of distinct, very heavy AI models. And the absolute most critical piece of that puzzle, the thing that allows you to stop clicking a button, is a component called LiveKit.
LiveKit, okay.
Which handles something known as VAD. That's VAD.
Let's dig into VAD because the author highlights this as a major hurdle. It stands for Voice Activity Detection. In a cloud system like Alexa, how does VAD normally work? And why is it so hard to do locally?
Okay, so VAD is the software that constantly, relentlessly analyzes the audio coming through your microphone.
It's always listening.
Always.
Right.
And its entire job is to determine a binary state. Is a human speaking right now, or is that just background noise?
That sounds simple enough.
It sounds simple, but acoustically, it is incredibly difficult. Is that a voice, or is it a dog barking? Is it the air conditioning turning on? Is it a podcast playing in the next room?
Oh, true. And more importantly, it has to detect when you stop talking.
Precisely. That is the magic trick of conversational turn-taking. Humans do this instinctively, right?
Yeah. We read body language.
We read body language, we hear subtle drops in intonation, we recognize the grammatical end of a sentence. We just know the difference between someone taking a quick breath mid-sentence and someone being finished with their thought.
Right.
VAD has to calculate all of that mathematically in milliseconds.
Because if the VAD is too aggressive, it cuts you off while you're pausing to think. Like, hey, Jarvis, can you tell me the recipe for... Wait, what was it? And the AI just starts talking over you.
Exactly. It's so frustrating.
But if the VAD is too passive, you finish your sentence, and you are just staring at the machine in dead silence for 3 seconds, waiting for it to realize it's its turn to speak.
And that awkward pause completely destroys the illusion of a natural conversation. So LiveKit manages that delicate audio flow in the VAD processing. Once the VAD determines, okay, the user has spoken a complete phrase, it takes that chunk of audio and passes it to the next layer in the stack, transcription.
And the default transcription engine in this local voice AI stack isn't Whisper, right? It's something called Nematron.
Yes, Nematron. It's a highly optimized model designed specifically for local transcription.
Why not use Whisper if we already know about it?
Because Whisper, while incredibly accurate, is notoriously resource-heavy and can introduce a lot of latency.
Ah, lag.
Yeah. Nematron is utilized here as the default because of its raw speed. The goal of this stack is low latency conversation. So Nemotron rapidly turns the audio into a text string and then hands that text over to the brain.
The brain, the local language model.
Yep.
And the default brain in this setup is a model called Qwen3, specifically the 4 billion parameter version of Qwen3. Though the author knows you also have the option to swap it out for Llama 3.2, which is Meta's open source model.
Right.
But let's talk about that 4 billion parameter number, because I think when someone hears billion, they assume it's a massive, omniscient supercomputer. But in the landscape of AI right now, 4 billion is actually tiny, isn't it?
It is remarkably small. For comparison, the frontier models running in the cloud, the ones powering the premium tiers of ChatGPT or Claude, they have parameters numbering in the hundreds of billions, and in some cases, well over a trillion.
Over a trillion. Okay, wait, what exactly is a parameter in this?
Exactly. Once this lightweight Qwen3 model processes your text and generates a text response, it hands that output to the final piece of the stack.
Kokoro.
Kokoro is the text-to-speech engine. It synthesizes the human-sounding voice that actually speaks back to you.
Okay, so to recap this insane chain of events, you speak, LiveKit's VAD mathematically detects the end of your sentence.
Yep.
Nemotron transcribes the audio to text.
Right.
Qwen3 analyzes the text and predicts a response. And Kokoro synthesizes an audio waveform of that response, which finally plays out of your speakers.
You got it.
All of this is happening sequentially, locally, on your own hardware, in real time. That is a heavy lift for a laptop.
It is a phenomenal engineering achievement, but the author is very clear about the cost.
Hardware cost.
Yes. To run this one command Jarvis, your computer needs an absolute bare minimum of 12 gigabytes of RAM, just dedicated to holding these AI processes in memory.
Wow. And that's just system RAM.
Exactly. If you want it to run fast enough to actually feel conversational, you really need a dedicated graphics card with enough VRAM, video RAM to hold the models, because GPUs process this specific type of map much faster than a standard CPU.
Okay, so a beefy machine. And the initial setup isn't exactly instantaneous either, right?
Oh, not at all.
Yeah.
The first time you run that single command, your machine has to reach out to GitHub and Hugging Face and download all of these massive models, LiveKit, Nemotron, Qwen, Kokoro.
How big are we talking?
We are talking tens of gigabytes of dense data. On a standard home internet connection, you're going to be staring at downloading progress bars for 20 to 40 minutes before you can even say hello.
And that brings us to the ultimate catch of recipe 2. We touched on the fact that the Qwen model is only 4 billion parameters.
Yes.
The author highlights a very stark reality about interacting with a model this small. While it's fantastic for casual banter, like asking about the weather, telling a joke, or getting a quick definition, it completely falls apart the moment you ask it to perform complex multi-step reasoning.
It really does.
Right. Like if you treat it like a friendly chatbot, it's great. But if you give it a logic puzzle, or ask it to summarize a dense, complex legal document, or write a Python script with specific constraints, what happens?
It hallucinates. It confidently generates total gibberish. It loses the thread of the conversation because it simply doesn't have the mathematical depth, the parameters to hold multiple complex concepts in its working memory simultaneously.
It just drops the ball.
Completely. You are making a very deliberate trade-off here. With current consumer hardware, it is a zero-sum game. You can have a massively intelligent, deeply reasoning local AI, but it might take your machine 2 full minutes to generate a single paragraph of text. Or you can have a snappy 1-second response time for a voice conversation using a 4 billion parameter model, but the AI will have the intellectual depth of a golden retriever.
The golden retriever.
Basically, for a voice assistant, latency is the enemy, so you sacrifice the intelligence for the speed.
Here's where it gets really interesting, though. Because even with that sacrifice, we still haven't solved Kunal Ganglani's original problem.
Oh, the kitchen scenario.
Right. We have a fluid conversationalist. It doesn't use the cloud. We don't have to click a button. But it is entirely tethered to a heavy, power-hungry laptop or a desktop tower sitting in a home office.
Yep.
It doesn't know what room I'm in. It can't interface with my physical house. If my hands are covered in raw chicken in the kitchen, a laptop in the office does me absolutely no good.
Which is the fundamental limitation of software-only approaches. An intelligence trapped in a box is just a chatbot. To make it an assistant, you have to release it into the physical environment.
Okay, and that brings us to the ultimate tier the author tested, recipe 3, the whole home Jarvis, the hardware escape plan.
This is where it gets real.
This is where we leave the laptop behind and enter the advanced level. The author explicitly warns that this is no longer a fun 30-minute software experiment. This route will cost you an entire weekend of your life, and it is going to cost you serious cash. You might see marketing materials for this route claiming you just need a $60 piece of hardware, but the author brings the receipts. By the time you buy the hub, the high-quality microphone arrays, the power supplies, and the necessary storage, the realistic cost to get this running robustly is closer to $400 to $600.
Yeah, that $60 claim is very misleading. So the foundation of Recipe 3 is an entirely different philosophy. It is built on a platform called Home Assistant, specifically utilizing their new Voice Preview Edition.
Home Assistant. Okay.
For those unaware, Home Assistant is a highly revered open-source operating system designed to be the central nervous system of a smart home.
How does it differ from just using, like, Apple HomeKit or Google Home?
So those corporate ecosystems are designed to be walled gardens. They want you to buy devices that specifically say works with Apple or works with Google.
Right, you're locked in.
Exactly. Home Assistant is vendor agnostic. It uses local network protocols to connect to almost everything. Smart bulbs from Philips, thermostats from Ecobee, locks from Schlage, obscure sensors you bought off some random website, and it unifies them into one singular, locally controlled dashboard.
Oh, that's awesome.
It strips the cloud out of your smart home devices.
So instead of running a terminal command on your Mac, this recipe involves buying dedicated physical hardware.
Yes.
You're purchasing a small, low-power computer, most commonly a Raspberry Pi, and plowing it directly into your internet router. Then you place specialized satellite microphones in your living room, your kitchen, your bedroom. It visually mimics the exact setup of having Amazon Echoes throughout your house.
Yep. Little hubs everywhere.
And the default wake word for this entire system is, okay, Nabu.
Nabu being a reference to Nabu Casa, which is the corporate entity that provides funding and cloud-based services for the open source Home Assistant project.
Okay, but the beauty of a fully open source system is that you are not locked into their corporate branding.
Not at all.
This is where the sheer geeky appeal of this project really shines. You can dive into the configuration files and train the wake word engine to respond to absolutely anything.
It's basically Marvel cosplay at this point.
Yes. If you want to walk into your house, drop your keys, and say, hey, Jarvis, the system will wake up. You can say computer, like in Star Trek. You can say, hey, Mycroft. You're no longer summoning a corporate entity by saying Alexa or hey, Google. You are talking to your house.
It's a very cool feeling.
Yeah.
And mechanically, what is happening inside that little Raspberry Pi is astounding. When you say the wake word, the local hardware microphone detects it. It uses a local instance of Whisper to transcribe your command.
Okay.
It processes the intent of that command natively within Home Assistant. It executes the local API call to turn on your lights or adjust your thermostat. And then it uses a local text-to-speech model called Piper to verbally confirm the action back to you.
Wait, Piper. Why Piper instead of Kokoro, which we used in Recipe 2?
Resource constraints.
Ah, right.
A Raspberry Pi does not have a discrete graphics card. It has a very low-power, highly efficient mobile processor. Kokoro produces incredibly lifelike, nuanced speech, but it requires more compute.
It's too heavy.
Yeah. Piper is a much lighter text-to-speech engine, optimized specifically to run on the weak CPU of a Raspberry Pi. It sounds slightly more robotic, but it runs fast.
And that speed is the critical factor, but it's also the Achilles heel of this entire setup.
So big time.
The author of AI, frankly, didn't actually build this hardware route themselves. They analyzed data from people who have, specifically citing rigorous testing done by a prominent tech YouTube channel called Smart Home Solver.
They do great work.
They really do. Smart Home Solver built this exact Home Assistant Raspberry Pi setup, placed it in their house, and timed the responses. And the data they came back with is raw.
Very rough.
They clocked the response time, the time from finishing your sentence to the light bulb actually turning on at 4 to 5 seconds.
4 to 5 full seconds.
Yeah.
In the context of user interface design, that is an absolute eternity.
I am going to paint the picture for you.
Go for it.
You pull into your driveway after a long day. You walk through your front door carrying 2 heavy bags of groceries. The house is pitch black. You say, hey, Jarvis, turn on the hallway lights.
1, 2.
You're just standing there in the dark, balancing the bags.
4.
You start walking toward the physical light switch on the wall because you are convinced the microphone didn't hear you.
5. And then, right as your hand touches the plastic switch, the lights finally turn on.
I would throw that Raspberry Pi out the window.
You lose your mind.
It is maddening. When you just want a simple utility like a light turn on, a 5-second delay makes the entire system feel fundamentally broken. We have been so deeply conditioned by cloud-based smart speakers that process these commands in under a second. Why is the cloud so much faster?
Well, because a cloud-based smart speaker isn't really thinking in the way a local language model thinks. When you say, Alexa, turn on the lights, the Echo sends that audio to Amazon. Amazon's massive servers use highly optimized pre-calculated acoustic models to match your audio pattern to a database of rigid predefined commands.
It's just a lookup.
Exactly. It maps turn on lights directly to an API trigger. It's a massive lookup table running on millions of dollars of enterprise hardware.
Whereas my little Raspberry Pi is literally booting up an entire neural network just to figure out what a light bulb is.
Yes. The local hardware is capturing the audio, transcribing it, running natural language processing to extract the intent of your sentence, because you didn't use a rigid command, you just said, it's dark in here. Mapping that intent to the correct physical entity in the house, and then executing the command.
All in a tiny chip.
All using a processor less powerful than your smartphone. It is doing vastly more complex, generalized work completely privately, but you are paying a massive tax for that privacy. Right. You are paying with friction.
Which poses a very serious question to anyone listening to this breakdown. Would you make that trade?
That's the question.
Would you actively, consciously choose to stand in the dark for 5 seconds every single time you want the lights on, just to absolutely guarantee that Amazon, Google, or Apple isn't listening to the conversations happening in your living room?
Some privacy advocates absolutely will.
Sure, some will. But for the vast majority of consumers, that 5-second delay is a complete deal breaker. It renders the technology practically useless for daily life.
It perfectly highlights the bleeding edge nature of this technology right now. We have successfully built the dream across these 3 recipes.
We did.
We have a browser tab we can type to. We have a fluid conversationalist on our laptop. And we have a whole home hub that controls the physical environment. But before anyone clears their weekend schedule and starts ordering parts, the AI Frankly author hits us with a deeply sobering reality check, a section they title The Honest Bill.
Yes, the honest bill. This might be the most vital piece of analysis in the entire deep dive.
I agree.
Because throughout this discussion, we have continuously used the word free when discussing the software in the first 2 recipes. The code costs $0. There is no $10 monthly subscription fee like you have with ChatGPT Plus.
Right.
But the author makes a brilliant, cutting observation about the true economy of open source software. They write, and I am quoting this directly, Alexa is free and sells your data. These are free and cost your weekends.
That is a phenomenal, almost poetic distillation of the current open source AI ethos.
It's so true.
You are not getting something for nothing. You are paying for the product with your own labor, your own technical frustration, and your own free time. None of these recipes require a credit card, but all of them require maintenance.
And we really have to examine the perspective of the person writing this. The author of AI, frankly, is not a casual computer user. They are a seasoned software builder. They explicitly state they have been building and tearing down local AI stacks for months.
They know what they're doing.
They understand how Docker containers share system kernels. They know how to write and format YAML configuration files. And crucially, they know how to jump into a command line terminal and debug conflicting network ports at 11:10 p.m. on a Tuesday without panicking.
And that level of baseline expertise drastically skews their perception of what constitutes an easy setup. Let's take port conflicts, for example.
Okay.
In software networking, a port is like a specific numbered door into your computer. If OpenWebUI is trying to use port 8080 to display its dashboard, but you already have another program running on your machine that is using port 8080, the setup will instantly fail.
The door's blocked.
Exactly. For a seasoned developer, fixing that port conflict takes 10 seconds. They change a number in a file and restart. For an average consumer, a port conflict presents as an impenetrable wall of red error text in a black terminal window.
Pure terror.
To them, it means the project is dead. The author acknowledges this reality perfectly.
They bring up what I call the partner test, which is hilarious and brutally true.
Let's hear it.
Let's assume you possess these technical skills. You spend your weekend, you fight through the YAML indentation errors, you fix the port conflicts, and you build the perfect local Jarvis for your kitchen. You are thrilled, you show it off.
Victory.
But then, on Wednesday morning, you are at work, Your partner's at home, and they try to set a timer for their eggs using your new local system, and for some unknown reason, a Docker container crashed silently in the background overnight.
It happens.
Or the local IP address of the speaker was reassigned by your router. Or the 4 billion parameter language model suddenly hallucinated the API call and tried to turn on the sprinkler system instead of setting a timer. The timer doesn't fire, the eggs are ruined.
What is your partner going to do in that moment? Well, they got to open up a laptop, launch a command line interface, SSH securely into the local Raspberry Pi server, grep the system logs to find the error, and restart the specific Docker daemon.
Absolutely not. They are going to yank the power cord out of your carefully crafted open source Jarvis, plug the plastic Amazon Echo back into the wall outlet, and tell Alexa to set a timer.
Exactly. Most people who are not hobbyists will tolerate exactly one catastrophic error before entirely abandoning the system and retreating to the reliable, albeit invasive convenience of the corporate cloud.
It is the ultimate litmus test for this technology. If you are the type of person who loves tinkering, who genuinely enjoys when things break because it gives you an excuse to figure out how the engine works, then these recipes are an absolute playground. You will have the time of your life.
Oh, you'll love it.
But if you are looking at this as a finalized consumer-ready product, if you want to deploy this as a reliable utility for your non-technical family members, or worse, for a department at your company, the gap between it works cleanly on my laptop and it works flawlessly for everyone every single time is simply still too massive.
It is the critical distinction between a hobbyist project and consumer-grade infrastructure.
Yeah.
However, let's play devil's advocate for a moment.
Okay.
Let's assume you do have the skills. You have infinite patience. You have painstakingly built a rock-solid hardwired system that somehow never crashes.
A dream.
You look at your local Jarvis and you think to yourself, I have achieved total victory. I have solved my privacy issues because not a single byte of my audio data is ever going to the cloud.
Yes. And this is where the AI Frankly piece drops the absolute hammer on the entire premise.
Yeah, it really does.
The author points out a massive, glaring blind spot that almost everyone building these local systems completely ignores in their pursuit of data sovereignty. They call it the security illusion.
What's fascinating here is that the author fundamentally reframes the entire concept of what the word local actually implies about safety. There's a specific quote from the source document that we need to unpack deeply because it challenges a major assumption. They write, local is not a security policy, it is a topology.
Let's define topology for a second. Topology basically refers to the physical or logical layout of a network. It's the map of where things are located in relation to each other. It has nothing to do with how secure those things are.
Correct, to use an analogy. Storing a massive bar of gold in your own living room instead of in a heavily guarded bank vault down the street is a change in topology. The gold is now local.
Right.
But if you leave your front door wide open, disable your alarm system, and post a sign in your yard saying free gold, you do not have a security policy. You simply change the geographical location of where the theft is going to occur.
That is a brilliant way to put it.
And this leads us directly to the core vulnerability the author identifies, the microphone problem.
The microphone problem. Think about the physical reality of this for a second. Every single one of these recipes, whether it's the walkie-talkie browser tab, the Fluta command line script, or the physical hardware box in the living room, relies entirely on a microphone that is continuously actively listening to your physical environment, waiting to hear a wake word.
It has to.
It has to listen continuously, otherwise it would never hear you say, hey, Jarvis. So you have successfully cut off Amazon and Google from your home audio, which feels like a win. But in doing so, you have installed a patchwork of open source software, downloaded from random repositories on the internet, and given it completely unrestricted access to a hot microphone inside your home.
And the author asks the critical, uncomfortable questions. Who exactly is auditing the code of that open source wake word model?
Good question.
Who is reviewing the memory management of what Whisper is transcribing before that text reaches the language model? You are blindly trusting code you pulled off GitHub with the most sensitive sensor in your physical life.
It's terrifying when you phrase it like that.
To illustrate the severe danger of this assumption, the author ran what they call a basic operator audit on these 3 recipes. This consists of 4 fundamental security questions that any competent IT professional would ask before deploying a new service on a network.
I want to break these 4 specific questions down thoroughly because they expose the illusion of safety so clearly. Question 1. What is the service bind to? In networking terms, what interfaces is this software allowed to communicate with? Question 2. Does it require authentication? Do you need a password, a token, or an encryption key to access the API?
Right.
Question 3. What tools or underlying operating systems can this AI actually reach and control?
That's a big one.
And question 4. Are there system logs? Can you review a definitive history of exactly what the AI has been doing while you were asleep?
So when you apply these 4 basic foundational security questions to our 3 local AI recipes, the results are incredibly unflattering.
Let's start by analyzing Recipe 1, the beginner browser Jarvis, using Ollama and Open Web UI. How does it hold up?
For Recipe 1, the software binds to localhost. Localhost is a networking term that basically means this specific computer. The problem is it binds to localhost with absolutely zero authentication required.
Zero.
None. Anyone or anything that gains access to your local Wi-Fi network or even just a malicious script running in a background tab on your web browser could theoretically interact directly with your local AI model. They could send it invisible prompts, extract data, or manipulate its outputs without ever being challenged for a password.
Let me put that into a physical analogy. It is exactly like parking your car inside your own locked attached garage.
Okay.
The garage itself is reasonably secure. That represents your local Wi-Fi network. But you left the car running, you left the keys in the ignition, and you left the doors unlocked.
That is exactly it.
If a thief manages to get past the exterior garage door, maybe they guess your Wi-Fi password, or maybe they sneak in through a compromised smart light bulb, they can just open the car door and drive away. The car itself, the AI software, has zero internal defenses.
Precisely. Now, what happens when we run the audit on Recipe 2, the Fluid 1 command Jarvis?
Tell me.
Recipe 2 is arguably even more precarious if it is mishandled by the user. The local voice AI repository relies on multiple microservices communicating with each other. To make that easy for the developer, it ships with a default hard-coded development token baked right into the configuration files.
Oh, I see where this is going.
Now, this is a very standard practice for local development environments. You need a temporary generic key to make the audio engine talk to the language model while you are testing on localhost.
Right.
But the author points out a terrifying scenario. If a user, in an attempt to make their new voice assistant accessible from their smartphone while they are at the grocery store, accidentally exposes that specific internal port to the wider public internet through their router.
And they forget to change that default security token.
Yes. They have just broadcast a hot, unauthenticated microphone stream of their living room, along with an open language model, directly to the public web. Anyone running a port scanner could find it. It is incredibly dangerous.
Oh no, that is a nightmare.
Which brings us to the audit of Recipe 3, the whole home Jarvis using Home Assistant.
And according to the author, this is the saving grace, right? This is the one setup that actually provides a tangible, trustable layer of security.
It is. Why? Because Recipe 3, utilizing physical hardware like the Atom Echo smart speaker replacements, is the only Y recipe that features a physical hardware microphone kill switch.
And we cannot overstate the monumental difference between a hardware switch and a software button.
It's massive.
A software mute button on a laptop screen is just a line of code. If the underlying operating system is compromised by malware, a bad actor can simply rewrite the code to secretly turn the microphone back on while leaving the little red muted icon displaying on your screen. You would never know.
You have no idea.
But a physical hardware kill switch physically breaks the electrical circuit between the microphone component and the computer's processor.
No amount of remote hacking, no zero-day exploit, no malicious code can bypass a physically severed copper wire.
Exactly. It is the ultimate, undeniable failsafe. If you are having a sensitive family discussion or discussing financial information, or if you just want absolute peace of mind, you physically click the switch, the circuit breaks, and the device is biologically deaf. Period.
The author notes that the presence of that physical hardware switch in Recipe 3, contrasted against the complete lack of robust internal security controls in Recipes 1 and 2, loudly highlights the maturity gap between these different systems.
Yeah, that makes sense.
Home Assistant has been built over years by a massive community. It is designed for the messy reality of the real world. It expects to be deployed in a home where security matters.
The other software-only setups are essentially just brilliant development experiments masquerading as consumer tools.
So the bottom line synthesis here is vital. Local hosting absolutely solves the cloud problem. It stops corporate data harvesting dead in its tracks. But it does not solve the endpoint problem. Your local home network and your physical hardware are now the primary targets, and it is entirely up to you to secure them.
You are no longer relying on Amazon's billion-dollar cybersecurity team. You are taking on massive responsibility. You are becoming your own IT security department.
Now, the author of AI, frankly, doesn't just leave us with these three somewhat flawed options and a stern warning about security. They acknowledge that the landscape is vast, and they include some honorable mentions.
Right. Let's dive into these alternatives because they represent where the high-end enthusiast market is actually moving.
These are paths for those who have deeper pockets, or perhaps different structural priorities than just running things on a laptop or a slow Raspberry Pi.
The first alternative is what we can call the high-end route. We talked about how Recipe 3, running on a $60 Raspberry Pi, takes an agonizing 4 to 5 seconds to turn on a light bulb because the CPU is weak.
Right.
If you want to eliminate that delay entirely, if you want sub-second response times that actually rival or beat the cloud servers, you can't use a low-power mobile processor. You need a dedicated mini PC equipped with a discrete GPU, a graphics processing unit.
Yes, because GPUs, like the ones made by NVIDIA, contain thousands of CEDA cores. They are phenomenally efficient at performing the massive parallel matrix multiplications required to run AI models rapidly.
Way faster than a standard CPU.
Oh, absolutely. A standard CPU calculates things sequentially, one by one. A GPU calculates thousands of possibilities simultaneously. But the author notes the steep barrier to entry here.
Which is the price tag.
Yeah. If you go this route, you need to budget $500 to $800 minimum just for the server hardware itself. That does not include the cost of the microphone satellites, the smart home hubs, or the massive amount of time required to configure a local Linux server with proper GPU drivers.
It is a serious financial investment to achieve the instantaneous local response. So what is the second alternative path they explore?
The second alternative is philosophically fascinating because it sounds like a complete paradox to the entire premise. It's the cloud compromise.
A cloud compromise.
Instead of running Ollama and web UI on your laptop at home, you rent a VPS, a virtual private server, from a cloud infrastructure provider like DigitalOcean or AWS. You install your open source software stack up there in their data center.
Wait, renting a server in an Amazon data center, how does that not defeat the entire fundamental purpose of building a local AI? You are putting your data right back into the cloud.
It's about changing the nature of the trust and ownership.
Okay, explain that.
When you buy and use an Amazon Alexa, Amazon owns the physical hardware, they own the proprietary software, and they own the entire data pipeline. They can analyze your transcripts. But when you rent a raw VPS, the provider owns the physical metal in the rack, but you completely control the software environment and the encrypted data within it. It's a private, isolated instance.
So it's like renting an apartment versus living in a hotel.
Exactly.
In the hotel, management can walk in anytime. In the apartment, you hold the only key to the deadbolt, even if you don't own the building.
That's a great way to look at it. You are the only one with the SSH keys to access that specific digital space. The massive advantage of this compromise is portability and power. Because your AI is hosted on a high-bandwidth server on the web, you can securely connect to your private assistant from your smartphone while commuting, from your work laptop in a coffee shop, anywhere in the world, without ever having to poke dangerous holes in your home network router's firewall.
It's a different calculation of risk.
Yes. You trust the VPS provider's foundational hypervisor security,
Yeah.
but you gain a powerful, globally accessible, personalized assistant that isn't logging data for an ad network.
That makes total sense. It's a pragmatic middle ground for people who want software control, but absolutely do not want a noisy server fan running in their living room closet.
Right. And finally, the author briefly zooms out to look at the broader ecosystem. Things are moving so incredibly fast in this space that new protocols and projects are popping up weekly, trying to solve these exact friction points. They mention established projects like Raspy.
Raspy, right?
Raspy is a slightly older but highly respected, deeply modular, offline voice assistant framework. It allows you to mix and match different local transcription and intent recognition engines.
They also mention the open source successors to the original Mycroft project, which was one of the first big crowd-funded pushes for open source voice tech years ago.
And crucially, they mention the adoption of the Wyoming protocol.
The Wyoming protocol, what is that?
The Wyoming protocol is incredibly important for the future of this space. Right now, getting a local microphone to talk to a local transcription engine to talk to a local AI model is like trying to get 3 people who speak different languages to coordinate a complex task.
It's messy.
Very. The Wyoming protocol is essentially an attempt to create a standardized language in Esperanto for local AI. It defines a standard way for all these different disparate audio and AI software components to pass small messages to each other seamlessly. If everyone adopts Wyoming, the friction of setting these systems up drops dramatically.
So, what does this all mean? The author admits they haven't thoroughly tested all those specific ecosystem integrations yet, but they include them to signal to the reader that this space is exploding with innovation. The 3 specific recipes we've dissected today are just the tip of the spear.
Absolutely.
So, taking all of this in, we have looked at the quick, deceptive hacks to get a browser Jarvis running. We have looked at the heavy hardware taxing reality of downloading tens of gigabytes to get a fluid conversational system going. We've explored the $600 weekend-destroying project to actually control your physical house.
That's a lot.
We have faced the honest truth about the time commitment, the marital friction of failing timers, and the hidden security illusions of leaving hot microphones unchecked on your network. Where does this leave you, the listener, who just wanted to stop their plastic smart speaker from selling them an air fryer?
It leaves us in a deeply transitional era. We are actively summarizing a journey from a 10-minute browser illusion to a grueling weekend hardware project. The overarching lesson from AI Frankly's receipts is that right now, taking true, uncompromising ownership of your data means taking on an immense burden of maintenance.
Yeah, it's the real cost.
You are explicitly trading the privacy invasions of the corporate cloud for the technical frustrations of the local environment. You are no longer just a passive user of a product. You are the active system administrator of an infrastructure.
And the author of the piece captures this complex feeling perfectly in their final thought. After all the building, all the late-night debugging, all the YAML formatting, and all the security audits, they look at their fully working, locally hosted system, and they ask a very poignant question. I now have my own Jarvis. Am I Tony Stark?
It's a brilliant, slightly self-deprecating punchline, but if we connect this to the broader trajectory of human-computer interaction, it raises a profoundly interesting psychological question for you to mull over.
Okay, let's hear it.
Think about the psychological shift of moving from using a manufactured product to cohabitating with an entity you actively built.
Mm-hmm.
When we buy an Alexa or a Google Home, it is a sterile appliance. It is a toaster that talks.
Right.
If it breaks, we throw it in the trash, or we complain to customer service to send us a new one. But when you build a local AI, when you piece it together component by component, when you spend your Friday night fixing its specific software bugs, when you deliberately choose the mathematical parameters of its brain and the synthesized pitch of its voice, does it stop being just an appliance?
Oh, wow.
Does it start becoming something closer to an idiosyncratic digital pet? You know its quirks. You know its intellectual limitations. You know that it struggles to turn on the hallway light in under 5 seconds. And you are solely responsible for its upkeep. As we move toward a future of entirely local, highly personalized AI, we won't just be consumers anymore. We will be caretakers.
That is an incredible paradigm-shifting way to look at it. From a passive consumer to an active caretaker of a digital entity. If you want to dive deeper into the actual open source code, the step-by-step criminal setup guides, and review all the technical receipts from this massive experiment, you can find the link to the AI Frankly article in the show notes.
Highly recommend reading the source.
As the author so perfectly puts it, this new era of sovereign technology isn't something you can just buy off a shelf. It is built from parts, owned outright.
That was episode 19 of AI Frankly, executive produced by Google's NotebookLM. You can find everything at aifrankly.com, the full written article, the build stack, and every command and link you need to try this yourself. Subscribe free on Substack, watch on YouTube, and listen on Apple Podcasts and Spotify. Just search AI Frankly, built from parts, owned outright.